AP Calculus AB, Unit 10, Day 11. Review for the test. So I thought maybe I could show you some of the answers real quick if you haven't checked them yet. Hopefully you've already checked them, but I will show them to you briefly. You can pause the video if you need to. So this is an extra credit review. And let's see, so here are sort of the top answers of the first 3 pages. 1, 2, 3, 5, 6, 8. 9's a free response, so I'll probably just wait to show you what I got. So pause the video if you need to. And then these are the answers at the bottom of these pages. Again, pause the video if you need to. Okay. So probably maybe your last practice for your test. Graphing calculators are going to be allowed on this test for any problems. Some problems they'll help you, some they won't. You gotta show the setups though. It's all about the setups. So it says and sometimes just I can set them up. So we're not even going to calculate this. So graphing calculator is not going to help you on this one. This one's very generic, but it says to find the area. Now to find the area, you want it to come out positive. So we want this area and this area in between the curves. Okay, so we're gonna have to break it up. We always want to do, to get the area, you want to do y top minus y bottom. And you want to do y top minus y bottom, but y top and y bottom change, so we're gonna have to break it up. So, our technique is always y top minus y bottom if you're doing it with vertical slices. Okay, which I think that's all you really have a shot at here. So the area is 0 to a, y top is the fx function, and y bottom is the gx function. The parentheses around all that, and then we're going to go a to b, and g is now the top function, and f is the bottom function. And that's it. So you can write this over here, 0 to a, f of x minus g of x dx plus a to b gx minus fx dx. So that's it. Okay, next one. This one's a little bit of properties of definite integrals that we've been doing for a while now. So remember that you can combine them if the top and the bottom match, and you just add them. So, and that would give you 6 to 9 here, be negative 2 plus 3 is 1. Okay, set the integrals to find the area, just set them up with dx and dy. So I might ask you to do it different ways. So we want to do dx would be vertical slices, y top minus y bottom. It's going to change, so we're going to have to break it up at this right here. We're going to have to do this chunk separate from that chunk. We do need intersections. You do have a calculator, which, if it's messy, then that might be better, but if I just set these equal to each other, this is pretty easy to do by hand. It's a lot faster. 16 commas 4, and then over here, set x squared equal to 4 squared both sides, plus or minus, x equals plus or minus 2. This is obviously negative 2. It's a negative y value. And this should be 0, 0. So, if it's hard, use your calculator, but I think that one is easier just do without that. So, vertical slices, we're going to have to do negative 2 to 0 first. Y top is 4. Y bottom is x squared dx. And then we're going to do 0 to 16. Y top is still 4. Y bottom now is square root of x dx. So that's the answer. Horizontal slices, you would do, let's see, so horizontal slices, we're going to draw it. Now, the nice thing about horizontal slices is there's only one set of them, x right minus x left, it's the same the whole time. So we're going to integrate in the y direction, 0 to 4, and x right in terms of y is going to be y squared. X left is going to be the negative square root of y, because you take square root of both sides, plus or minus. This time, we're going to go with the negative because it's the left half of the parabola. Those are definitely negative x values, right? So whatever you're plugging for y, you should get a negative answer out. So, that's good enough. You can clean it up if you want to, or change the minuses to plus plus. Now, you're not asked to calculate these, but if you wanted to, if you were to calculate both of these in your calculator, they should both give you the same answer. If they don't, something's wrong, or you just typed it in wrong. They might be perfect, actually. People often make mistakes just typing them in. So you would just put these, over here in your answer column. 2 to 0, 4 minus x squared. You need the parentheses, need the dx. I will take off points for little stuff like that. Not a lot, but if you keep doing it, it's going to add up, right? And this one is going to be 0 to 4 of y squared plus square root of y dy. Okay. All right. Next one says the line y equals k divides the enclosed area into two parts A and B such that the ratio of the areas is 1 to 2. So this is 1 part to 2 parts. In other words, there's 3 parts total, so this is 1/3 and this is 2/3 of the entire area. You can use your graphing calculator. You go show setup. So we've done a lot of these problems before, back on the first lessons of this unit, and so I'm on the pretest. So the first thing you got to do is you got to find the entire area. Now you know that you're going to have to do it with horizontal slicing for the second part because you're doing y equals k. So it might be better to just start with that approach from the beginning, but it's up to you. You could do vertical slicing. And it's just going to be the area under the square root function, which is pretty easy to set up. And you have a graphing calculator, so you just got to show your setup and label your work and stuff. So math 9, square root of x, comma 0, comma 9. You can do it by hand too. It's going to be 18.000000025. I think it's technically exactly be 18. Or you could do, horizontal slicing, x right minus x left, which you're going to have to do at some point in this problem anyways. This is 9 comma 3. Just plug 9 in the square root of x. Square root of 9 is 3. So if we did that, we would do 0 to 3, and x right is always 9, and x left, in terms of y, is y squared. So you could do that instead. You could do that by hand if you want, but might as well take advantage of your calculator. Math 9 minus x squared comma x. We put x's for the y's, right? Because that's all our calculator does. And that one turns out real nice. They just say it's 18 perfectly. So either one you can do. Now, so that's the first part. You got to find the total area. Now, do you want to do, it says, do you want to find this area or this area? 0 to k or k to 3? I personally am always a fan of 0 to k, so I'm always going to do the bottom part first. So I'm going to say, all right, we want 1/3 of the area. And we're going to set it equal to 0 to k, and this is where you have to use horizontal slicing. You have to use horizontal slicing to find y equals k. Because essentially what we're going to do is we're going to integrate this and keep adding the area until it perfectly is 1/3. You can't do that with vertical slicing. to meet a horizontal line. If they told you x equals k originally in vertical line, then you would do it with x. So this is going to be 6 equals 9y minus y cubed over 3. So you got to find, this is probably the one integral you actually have to integrate, like find the antiderivative, because you get to use your calculator for everything. Plug k in, plug 0 in. Now we got to solve this equation. Maybe you could do it by hand, but even if you could, I don't know, unless it was super easy, I think I'm going to use my calculator. So I'm going to move everything one side, either side. Set equals 0, like I would if I were to do it by hand anyways. And then you guys should be really good at solving equations on your calculator. The best way to do it is just put it in to get it equal to 0, one equation, and find its x-intercepts. So and then you want to set the window to the right. We expect it to be between 0 and 3. You don't want to make the windows too small or too big because it might show you answers that we're not going to look at. And we just want to find the x-intercept. So I'm just going to keep the y min and y max at -1 and 1 because I just want to focus on this. So there's the answer. Should only be one answer. So I can calculate 0 x-intercepts between 0 and 1, 0 and 1, maybe guess 0.6. And there's the answer. K equals 0.678, 3 decimal accuracy for final answers. Rounded or truncated comes out the same. This is the level of work you have to show. Okay. So I might ask you for the setup over here. The setup would probably be like this guy right here. 1/3 k cubed minus 9k plus 6 equals 0. And then we used our graphing calculator. This is what we used our graphing calculator for, to find the answer. So you're going to have a problem like that on your test. You know how to do it. Okay, volume by cross section. You know that's coming also. Now, volume by cross section, you don't get to choose whether they're vertical or horizontal slices. You are told what they are. Most of these problems you could do different ways, vertical or horizontal slicing, but these problems, actually, it changes the answer if you don't follow it. The base is solid, y equals x, 4x squared, that's parabola, right? And then lines 2 and 5. So this is the base region that we're going to build volume off of. Cross sections are perpendicular to the x-axis, so they got to be vertical this time. And they're going to be a square with a circle taken away. So you can just draw one slice in, perpendicular to the x-axis. Set up the interval to find the volume, and then use graphing calculator to evaluate it. So the volume is going to have some common area in terms of x, which is going to be a square minus a circle, which is going to be side squared minus pi r squared. Now we want to get all the r's and s, and we want everything to be all s's or all r's. And so I think we want to go with the side because you usually want to use the side of the shape that's touching the base region as your dimension. So s equals 2r, so r equals 1/2 s. I mean, you could change everything to r, but I think it's going to be more convenient to use that full length, if possible anyways. So that's going to be, radius is s over 2, and it all gets squared. The division by 2 gets squared also. So you could factor out the s squared, just leave the s squared in and have a 1 minus pi over 8 out in front if you want. The limits are going to be in the x direction, 2 to y. Your s right here is going to equal y top minus y bottom. Y bottom is 0 here, so y top is going to be 4x squared. 4x squared squared minus pi over 8. The 2 get, or pi over 4. I'm used to semicircles, pi over 4. 4x squared squared dx. So this could be your setup. We could clean it up too. I mean, you could clean this up a lot of different ways. You could say, well, I'm going to take the 16 minus 4 pi out. And then I'll just have x to the fourth inside. That's kind of a nice clean version of it, but whatever. Or you could leave everything inside and just say, okay, well, this is 16x to the fourth minus, it's going to be 16 4 pi x to the fourth. And you do that, whatever. I mean, I'd probably clean it up a little bit before I plugged in my calculator, because so we're going to do math 9. We could just do this one, whatever, 16x to the fourth minus 4 pi x to the fourth, comma x, comma 2, comma 5. And the answer is 2124.043. 3 decimal, actually rounded truncated, comes out the same this time. So I'm going to write our setup over here. Volume equals 2 to 5, 16x to the fourth minus 4 pi x to the fourth dx. And that was 2124.043. Okay. Solves the revolution. You know you're going to have some of these. You're going to have to do shells and you're going to have to do washers. Just go washers. So then we'll find the volume of the solid using dx. So this is just kind of when it's being rotated around the y-axis. So the first thing I would do is I would draw the reflection of the shape. Kind of try and get it right. Something like that. Now, if we're going to do dx, it's a vertical slice, which is parallel to the axis rotation. So you know it's going to give you shells. It's going to give you shells. And the way you find the volume of a shell, if you guys remember, right? You have a shell, and you cut it open. It's a big rectangle. And this right here is the circumference around the shell. It's this right here. It's 2 pi r times the height dx. We're going to integrate in the y direction, or in the x direction. So a to b. We always base the limits and everything off this region. Don't go outside of this region at all. This is just for looks. Don't even go over here. So it's going to be a to b. The radius is x right minus x left. But it doesn't depend on these curves. It's touching this curve. It's touching that curve. So whatever x we're at, minus x left is 0. So it's just x. The height is the thing that depends on the curves. That's y top minus y bottom. The size of the height changes as you move along the curve. Y top in terms of x is f of x. Y bottom in terms of x is g of x. And that's your setup for this sort of generic problem. Okay? So volume equals 2 pi a to b x f of x minus g of x dx. All right, now for one with some real numbers. R is a region bounded by y equals x plus 6, so that's a line. Y equals x squared, that's a parabola. So this is the region, and x equals 0, so this is the region. It's going to be revolved around the x-axis. So I'm going to try and draw sort of the mirror image of it, just to get a better view of it, make better slices. Part A, we're going to do dx. So dx is going to be vertical slices, which are going to be perpendicular to the axis of rotation, which means they are going to be washers this time. So a washer is a disk. It's a circle times the thickness, pi r squared, dx, minus a smaller one missing from the center. We go in the x direction. Okay, so we do need this intersection. And we could graph these on our graphing calculator and find the intersection of two curves. That might take longer than just working it out by hand. It would be x squared equals x plus 6. X squared minus x minus 6 equals 0. X minus 3x plus 2 equals 0. X equals 3 and negative 2. So should it be 3 or negative 2? It's going to be 3 because it's positive. And you're going to get 9. Plug in both, you get 9. The negative 2 is over here. where they intersect way over there that we don't care about. Okay. All right, so we got the intersection, probably faster than doing it on our calculator. This is 0, 0. This, you should just plug 0 in here. It's 0, 6. So our big radius, and then we have our little radius. Y top minus Y bottom. This is also Y top minus Y bottom. Now, Y top is just the Y coordinate along this curve in terms of X is X plus 6. Y bottom is 0. Y bottom is 0. We're going 0 to 3. So we had to find the intersections, figure out the limits. The little r is Y top along this curve in terms of X is X squared. Minus bottom is 0. And that's it. That's your setup. That's good enough. Now we're going to find the same volume, same shape, but with dy slices. Now dy slices are going to be horizontal, and they're going to be parallel to the axis of rotation. So you're going to get shells. Problem here is we're going to get two different sets of shells. We're going to have to set up two different intervals of shells because the height changes between what curves determines the height. So we're going to have to do from 0 to 6 and then 6 to 9 separately. So we're going to need 2 pi rh dy and then another 2 pi rh dy. So we got to go 0 to 6, we got to go 6 to 9. So 0 to 6, this is the radius. It's y top minus y bottom. And y bottom is 0, y top is whatever y we're at. The height is x right minus x left. X left is 0. X right is this x coordinate in terms of y, which would be the square root of y. This radius is also y top minus y bottom, and y bottom is 0, and y top is whatever y we're at, which is pretty common with shells. You might add subtract a number if your axis rotation is not exactly in the x or y axis. The height up here is x right minus x left. X right is along the parabola, it's the square root of y. X left is this x coordinate in terms of y, so that'd be y minus 6. But you better put parentheses around it or distribute it correctly. But that's your setup. Now, if you plug both of these in your calculator, they should give you the same answer, which you're not being asked to do. But if you had a few extra minutes, you might just try it. But if they don't come out the same, that can mean they're both wrong. One's wrong. It can mean they're both right. You just entered in one wrong. So, don't erase everything unless you can find your mistake. Okay, we got another one of these. Okay, set up the intervals. Do not evaluate in terms of x, in terms of y. So we'll rotate around x equals that. I'm going to try and sketch my picture here. So x dx would be vertical slices, which will be parallel to the axis of rotation, which will give you shells, right? You should know that. You shouldn't depend on after the drawing to figure out if it's a shell or not. If you don't know it's a shell ahead of time, you're probably going to draw something weird. You should know. Parallel to the axis of rotation gives you shells. So the volume is going to be 2 pi rh x dx. So it's going to be 2 pi. The limits are going to be in the x direction. So it's going to be 0, 0, 6, 0. This is going to be 6, 6. This is the original region. Everything should be based off that. Dimensions, limits. So I'm going to go 0 to 6. The radius is x right minus x left. X right is 8. X left is whatever x we're at for shells. 8 minus x. The height is the thing that depends on the curve. So that's going to be y top minus y bottom. Y bottom is 0 here. Y top in terms of x is the square root of 6x. So that's your setup. Okay, we're going to do it. We're going to try and also do it with horizontal slicing. If you draw these far enough apart from each other, then that might be okay. Otherwise, I'm really suggesting in the test, I would draw two separate pictures. I'm going to give you a lot more room. I would just redraw it. It's going to help you not mess it up. It's going to help me give you partial credit when something's weird and I look at your picture trying to figure out what you're doing. These are going to be washers. So it's going to be pi big R squared dy minus pi little r squared dy. And we're going to go in the y limits, so 0 to 6. Now, the big radius is x right minus x left. X right is 8. X left is this x coordinate in terms of y, so that's going to be y squared divided by 6. 8 minus y squared divided by 6. Little radius is going to be right here. It's x right minus x left also. Its x right is 8. Its x left is always 6, so it's just going to be 2 squared. That's it. That's good enough for me. Now, you could check your answer if you want. Calculate both these on your graphic calculator. They should come out the same, as long as you typed everything in correct and whatever. All right, here's free response problem, which kind of involves a lot of the different things that are throughout this chapter. So we have this crazy function here. You're allowed to use a graphing calculator. Let R be the region in the second quadrant, so just this chunk right here. Let S be the shaded region over here that's bounded by the graph of f and the tangent line. So that's the tangent line. So if we're going to find R, that's just a y top minus y bottom. It's really just the area under that one curve. So it's just going to be f of x. I mean, you could actually write it. They named it f of x, so you're okay with that. The one thing you need to figure out is you got to figure out the limits. Really, just one limit. This is for sure 0. 0, comma 3, I think. You plug 0 in here, you get 3. Yeah. This right here, though, that's a x-intercept, which you could set this equals 0 and try and solve it, which I don't think you're going to be able to pull that off. So the way you did is you just graph this. X to the third divided by 4 minus x squared divided by 3 minus x over 2 plus 3 cosine x. Window looks like maybe -2 to 4, -2 to 4. You want a graph. You want a good graph. You don't want to waste time having to zoom in and out or go back and change it. So try and as much as you can. So we want to know this x-intercept right here. Second calc, 0. Looks like it's between -2 and -1. I'm going to guess -1.5. And I want to carry these extra decimal points, -1.373122. Now here it says 1.2 e to the -13. That's scientific notation. That's 1.2 times 10 to the -13th, which is like 12 zeros. So it's pretty much 0, right? Okay, which is what we're trying to find. So it's going to be -1.373122. Okay, that's the setup, which is going to get you points. And then we're going to calculate. So the point breakdown here is going to be 2, 4, 3. And the setup was 1 point. And then the answer. Now here, we could go ahead and integrate here if you want. I rarely integrate from the screen because you can only do one graph and usually don't even have the graph. And it does take a little longer. Now you need to type it in. Do not press enter right now. Even though it's going to be really close, it's off in the second decimal place already. It's going to mess up your answer. Type it in. You never use trace for limits. Type them in. The nice thing is it does confirm that it did the area that you thought it was. So 2.903 0944. I'm going to just write these. I don't know if I need this for some other problem later on. So I'm just going to write down the extra decimal so I don't have to redo it later for some reason. So that's point. Okay, part B says find the volume of the solid generated when R is rotated about a horizontal line y equals -2. So the one we just did, we're going to rotate it about y equals -2. I think I could pull this off on this picture right here. So it's going to be rotated around this. And, I think we're probably going to want to just go with vertical slicing, which would give you disc washers. Because if you're going to do horizontal, you're going to have to solve this x in terms of y, that's just not happening. So I think that's totally out. Any horizontal slicing in this problem is just not going to happen. So the volume is going to be pi r squared dx minus pi little r squared dx. And then we're going to integrate. Now the limits are going to be negative 1.373122 to 0. The radius, the big radius right here, y top minus y bottom. So y top is f of x, y bottom is -2. And you could just write f of x in here. I mean, you could write this whole thing if you want, but they named it f of x, so you're allowed to use that, which makes writing it a little easier. Minus negative 1.373122, which is 0. The little radius is y top minus y bottom. It's 0 minus -2 squared. So that's going to become positive. So this is good enough for your setup. And then we're going to calculate it, I think, right? So go ahead and put it in our calculator. Now, f of x is my first equation here. So it's going to be way quicker to do this on the home screen. Pi, math 9. But let's go ahead and take advantage of vars y1. We need to put parentheses around it. Plus 2 squared comma x comma negative 1.373122 comma 0 minus pi math 9 4 comma x comma negative 1.373122 comma 0 close. This should do it. 59.361, 3 decimal, actually rounded truncated. Points on this, there was 4 points. Point for the limits and the constant. Probably a point for each of these integrands. And then a point for the final answer being correct. C, write but do not evaluate an integral expression that can be used to find the area of S. Well, to find the area of S, we got to find the equation of this tangent line first. So we got to find the equation of the tangent line first. So you need derivative and a point. We got a point. We actually got the y-intercept. That's easy. We just need the slope. You could use your calculator. It might be faster to just do this by hand. It's going to be 3x squared over 4 minus 2x over 3 minus 1/2 minus 3 sine x. I mean, that's the derivative. And we want it at 0, which all these are going to be 0 except, this is going to be 3/4 times 0 squared minus 2/3 times 0 minus 1/2 minus 3 sine of 0, which is 0, 0, 0. So the derivative is at 0 is negative 1/2. That's your slope. You already have the point f of 0 equals 3, or you could calculate it pretty easily. So the equation of tangent line is going to be y minus 3 equals negative 1/2 x minus 0. And probably want to change the slope intercept form. Y equals negative 1/2 x plus 3. So that's your equation of your tangent line, which is a point of the 3 points, by the way. And then we want to find the area between it. So we're going to do y top minus y bottom. So the y top is going to be -1/2 x plus 3, and y bottom is going to be f of x. You can write the whole thing out if you want. Now the one thing we need is we get a limit starts at 0, but what's this point right here? So we got to find that intersection between those curves. So if we want to do that, we go to y, add our tangent line, -0.5 x plus 3, graph it, and then we find the intersection, second calc, 5, first curve, second curve, guess 3.5, otherwise it's going to find this one. So I'm going to write that. I'm going to picture 3.3898677, comma 1.3050662. You better carry more than 3 decimal places in the middle of your work. That's your upper limit, 3.3898677. That's the setup. And they said not to evaluate it, so you're good. The limits here were a point, the integrand was a point, the tangent line was a point. So that's it. I mean, you can calculate it if you want, but they didn't ask you to. So let's see, we've got one more. So these free response problems are out of 9 points on the AP test. This is 2, 4, 3. Point breakdown changes every time. So it says let f be the function this. So they're giving you that function 2x, 1 minus x. And then g is the function 3x minus 1 square root of x, 0 to 1. A says find the area of the shaded region. Well, probably want to do vertical slopes. I think I think we want to do vertical slices, y top minus y bottom. Solving these for x in terms of y is gonna be gross. I don't even know if it's possible. So let's just stick with vertical slicing. So the area is we're gonna integrate from 0 to 1. Y top is f of x. So we can just write f of x. Y bottom is g of x. So we can just write g of x. They named them that way. You do need to put parentheses around everything. But they gave us these names, so we can use them. This is your setup, which is worth a point. And then we're going to calculate it on our calculator. I mean, we might be using these equations a bunch, so it could make sense to type them in, not to graph them, but to just use the vars y vars thing. So I'm just going to put them in there and just got to make sure you remember which one is where. Because I'm going to do it from the home screen. I'm going to say math 9, and I'm going to do it's going to be vars y vars function y1 minus vars y vars function y2, comma x, comma 0, comma 1. $1.133333556. I'm just going to write all these down just in case I need it later. But your official answer should be just 3 decimals rounded or truncated. It comes out the same. So that's the other point. Part B says find the volume of the solid generated when the shaded region enclosed by the graphs F and G is revolved around the horizontal line y equals 2. So there's a line up here. I'm just gonna say it's like right here just to fit it. And then I'm just gonna kind of draw like a rough sketch. So if we do vertical slices perpendicular to the axis of rotation, we're gonna get washers, right? So the volume of a washer is pi r squared dx minus pi little r squared dx. We're going to integrate. Limits are 0 to 1. The radius, the big radius, is y top minus y bottom. Y top is 2. Y bottom is the y value down here, which is gx. For the little radius, it's also y top minus y bottom. And y top is 2, and y bottom is the y value along this curve. So it's going to be 2 minus f of x. So that's your setup. I don't think we want to do shells because, like I said, I don't think you're going to be able to solve these for x in terms of y. So that's going to make that a problem. We can put this in our calculator. Now remember, f of x is y1. So I'm going to do pi math 9 2 minus vars y vars function y2 close squared comma x comma 0 comma 1 close minus pi math 9 parentheses 2 minus vars y vars function y1 close squared comma x comma 0 comma 1. So I just typed it all in, all one line of calculations, and I get 16.17920.316 for my answer. I'm going to say 16.179, 3 decimal accuracy, rounded truncated. Comes out the same. So that was 4 points. 1 point for the constant and the limits. 1 point for each integrand. 1 point for the answer. C says, let h be a function. H equals kx 1 minus x for 0 to 1 for each k greater than 0. Region not shown enclosed by the graphs h and g is the base of a solid whose square cross sections perpendicular to the x-axis. I'm going to redraw this real quick. Okay, so this is the base. This is volume by cross section. They're squares, square cross sections. There is a value k for which the volume of the solid is 15. So I'm going to draw one cross section. It's a square. Right? And this is a, oh, actually it says, there's a new function, hx. I don't really know what it looks like, but it's kx 1 minus x. It's pretty much like the original f of x function, but it has a k instead too, which is just going to be a different number. It's going to make it taller or shorter. So just roughly, we can kind of graph it the same. And then this is still gx. So they're introducing this new hx. This is graphs enclosed by the graphs of h and g. So this is that new one, and g is the bottom one from before. Cross sections are perpendicular to the x-axis. They're squares. There's value k for which the volume of the solid is equal to 15. Right, but do not evaluate, do not solve an equation involving an integral expression that could find the value of k. So there better be k's in it. It better be equals, left side, right side. So this is kind of like the problems where we're trying to find the line that cuts it exactly in half or something because we know the area. This time we know the volume. It's going to be this is volume by cross section. It's going to be some general area in terms of x. They are squares this time, so it is side squared. So it's going to be 0 to 1. The sides are going to be y top minus y bottom. Y top is this h function, y bottom is g function. So it's going to be hx minus gx squared dx. Okay, so this is going to give you the volume, and then it needs to be equal to 15, they said. This is it. This is an equation, two sides, equal sign, involving integral. K is in it. I mean, we could rewrite it and put kx, 1 minus x there instead. And even for gx, we could write 3x minus 1 square root of x. I don't think you need to do this, but this is the same thing. They told you don't have to find the answer. I think we could find the answer. It would take big work. We would have to integrate this by hand. But this was worth 2 points, and setting equal to 15 was worth 1 point. So that's it. Some good practice for your test. Okay.